Okay, Common Core Algebra 1 videos of the year for y values that we're going to get. We'll also then identify some characteristics of an exponential graph, like y-intercept, x-intercept, that kind of thing. And finally, we'll actually draw the graph with a table, which we've done a couple times this year, or for linear graphs and for quadratics as well. Okay, so first piece, just as a reminder, an exponential function, remember, is anything that has the form y equals b to the x, or we also used what was called function notation and said f of x equals b to the x. Okay, so either one of those would be an exponential function. Now, we've talked about growth and decay exponential functions. So a growth function graph is always going to rise from left to right. A decay function graph is always going to fall from left to right. And they're going to start out really gradual, and then it's going to get pretty steep. So that would be an example of a growth function. Whereas a decay is falling from left to right, so it's going to be really steep falling and then kind of start to level out. Okay, the other things we're going to talk about then, our domain, we talked about last time, is all real numbers, and our range is all positive numbers. So we would write all positive numbers for the range, because remember, range is y, as greater than 0. Okay, it will never be equal to 0, and it will never be negative. A couple other things is every exponential graph has what is called a horizontal asymptote. And a horizontal asymptote, definition of that, is a line the graph approaches but never actually crosses. So it's going to get really close to it as x gets really big or really small, but it's never actually going to cross it. And for our graphs, the y equals 0, or the x-axis, is always your horizontal asymptote. So it's probably easiest just to remember your x-axis. Your graph is always really going to get really close to it, but never going to actually cross it. Another important characteristic is the y-intercept, and the y-intercept is always 0, 1. Reason for this, if you think about our form, y equals b to the x, well, it really doesn't matter what b is, because here we know what x is. So that would say that y equals b to the 0. And if you remember our properties of exponents, anything to the 0 power is 1. So that tells us whenever x is 0, y is 1 for these exponential functions. Okay, so let's look at an example of one. We have f of x equals 1.5 to the x. So I'm going to create a table just like we did in the last video. I'm going to take 1.5 to the negative 1, and I get a decimal, 0.667 to the 0. Remember, anything to the 0 power is always 1. Take it to the 1, I get 1.5, 2, 2.25, and 3, 3.75. Okay, so we have those numbers, and now we're going to use those to draw a graph. Okay, so 0.667, 1, 1.5, 2.25, and 3.375, all corresponding with your x values. So if I go to my grid here, we're going to try to figure out what this looks like. So at negative 1, we're at 0.667, so about 2/3 up at negative 1. That's our first one. At 0, we're 1, and remember that makes sense. Our y-intercept is always 1. At 1, we're at 1.5. At 2, we're at 2.25, and at 3, we're at 3.75. Okay, so you can kind of see we're starting to get steeper and steeper here. Now remember, we want to get close to the y-axis, or the x-axis, but we're never going to pass it because this is your horizontal asymptote. Okay, so we're never going to drop below this y-axis. We can get really, really close to it, and we really want to just kind of keep coming down and approaching it, but never actually cross it. And then if we can, just kind of smoothly connect those points. It's kind of hard with this, and we should be increasing. So remember, this is a growth function, so it should look some smooth curve like that. Hopefully you can draw yours a little smoother than I did there. Okay, if it had been a decay function, we would just be coming down and getting really close to that x-axis, but not actually crossing it. Okay, so that is it for our graphing exponential functions. Biggest thing is that we're going to have a table and plugging in the values like we did in class and figuring out what those values are, and then we can graph our points and draw a smooth continuous curve. See you next time.